From the CUBE studios in Palo Alto and Boston, bringing you data-driven insights from the CUBE and ETR. This is Breaking Analysis with Dave Vellante.
At CES 2026, Jensen Huang once again reset the economics of AI factories. In particular, despite recent industry narratives that Nvidia's moat is eroding, our assessment is the company has further solidified its position as the hardware and software standard for the next generation of computing. In the same way that Intel and Microsoft dominated the Moore's Law era, we believe Nvidia will be the mainspring of tech innovation for the foreseeable future. Now, importantly, the previous era saw a doubling of performance every 2 years. That was Moore's Law. Today, Nvidia is driving annual performance improvements of 5x, throughput of 10x, and driving token demand of 15x via Jevons paradox. The bottom line is that ecosystem players, partners, and customers must align with this new paradigm or risk a fate similar to that of Sisyphus, the beleaguered figure who perpetually pushed a rock up the hill. In this breaking analysis, David Floyer and I build on our previous breaking analysis, that was episode 300 last month, with an update to our thinking. And we'll start with an historical perspective, looking at the fate of firms that took on Intel in the PC era and how the survivors made it through. We'll then turn to what Jensen announced at CES, why it changes the economics of AI factories, and we'll help you understand the demand dynamics of performance and throughput. And then we'll close with what does this mean for competitors like Intel, Broadcom, AMD, and other silicon specialists? What's it mean for the hyperscalers, leading AI research labs, OEMs, and customers with regard to AI strategies and spending implications? David Floyer, welcome to this episode 301 of Breaking Analysis. Good to have you.
This is amazing stuff from Nvidia.
Yeah, very impressive. I'll tell you one thing. Jensen has set a new bar in terms of 2-hour keynotes. He didn't quote quite for 2 hours, but it was Jassy on the mantle. Jensen's, their simulation and their graphics are just incredible. And he has a lot of fun up there. He's got a great sense of humor, and he's kind of cute. All right, let's get into it. So, Alex, you bring up the first slide, companies that took on Intel in the 80s and 90s. David, I love this list that you compiled. You know, IBM was, of course, the dominant player. So you've got a list of companies here that tried to compete with Intel in the 80s and 90s, risk players, a number of other folks, Sun Microsystems, a lot of young people never heard of them. And the green are the ones that made it through the knothole, right? That was the intent here.
That's right. I mean, it's coming back to what Intel provided in terms of what you said, the doubling every 2 years of performance and of price performance. And the important thing here was that they kept their foot on the pedal all the time throughout this and just drove and drove and drove Moore's Law. And as a result of it, others just could not keep up.
Why isn't Apple in the green? Is that a mistake? Apple should be in the green.
Apple should be in the green. Yeah. Oh yes, of course Apple.
That's what I leaned on my friend Gemini for some of these charts, and so sometimes it makes mistakes, but we'll fix that. Apple definitely made it through. And so actually, let's double down on those companies that did make it through. Alex, if you bring up the next slide. So you've got AMD Acorn, which you shared with me, was the original ARM. Apple, of course, Apple made it through. TSM, Intel, and Nvidia. Let's go through those for a minute. I mean, IBM, or AMD rather, why did AMD survive, David?
Well, as part of the introduction of the first PC, IBM demanded a second source and put a mandate on Intel that they would share it with another supplier. And AMD were that supplier. And as a result, they have continued to get the instruction sets from Intel, and nobody else could.
Well, and ARM, of course, along with TSM, and of course Apple as well, completely changed the whole notion of that Jerry Sanders put forth, which is real men own foundries, own fabs. So those three companies in particular changed that. Of course, Nvidia as well. And then, Intel was that virtual combination, as you're showing here, of Microsoft and Intel. We'll come back to some of the competitive implications. But go ahead. You have another comment there?
One point I want to make on that is volume. Volume was the key thing that drove the success of all of those people. Volume in a different segment, an allied segment.
Actually, Alec, go back to that slide. I want to ask David a question on that. So you're saying AMD had sufficient volume, but it was kind of forced by IBM. ARM wafer volumes are, orders of magnitude larger than x86 now. Apple, of course, has volume. We know that's how TSM got on the curve. Its costs are probably 30% lower than Intel's. Intel won because it beat RISC because it had the volume from PCs, and then it lost the current battle to ARM and Nvidia and TSM. And of course, Nvidia, your premise is that they are going to be the volume leader by far of this era.
Absolutely, yeah.
Okay, let's get into what Nvidia announced. Alex, if you bring up the next slide. This was pretty remarkable. And Jensen talked about this, not just a chip, it's 6 chips. So they announced Vera Rubin, named after the great astronomer. She figured out somehow, this is like genius material, figured out that the tail of the universe was moving as fast as the core, and then explained it with dark matter, and wow, that's just incredible. So what an homage to a great scientist. But anyway, Vera is the CPU, and I want you to talk about that. Rubin is the GPU, but there's much more to it. There's the NVLink, which comes out of the InfiniBand. There's the ConnectX and SpectrumX, which is Ethernet. There's the DPUs, the Bluefield, and then there's the SpectrumX Ethernet co-packaged optics. What's interesting here, David, is that, a couple of years ago, the narrative against NVIDIA was that Ethernet's going to dominate. And so and NVIDIA said, yeah, we agree. And then they came up with SpectrumX, and now Jensen claims that they're the #1 networking company on the planet, and they probably are in terms of revenue. So that's quite remarkable. But Alex, if you go back to that slide, I wonder, David, if you could take us through here, through this. And in particular, Jensen talks so often about extreme co-design. Some people infer that means they're co-designing with the ecosystem. And while they are, it starts with co-designing across their portfolio. But take it from here, please.
Yes, sure. The co-design is also, of course, they are working with the OpenAIs and Gemini and XAI, all of those, their customers. They're working with them in particular, but then they're working within it on the software, on redoing the complete chips to do 6 chips of very high quality across the whole of their machine. Every major chip has had a major enhancement. And so it's not just the GPU, which it's got a 5x improvement. It's not just the front end CPU, the 2 CPUs around it. It is enormous improvements in the networking in each of those areas, networking within the rack, networking between the rack. All of these chips have been redesigned together to maximize the throughput through it. So each of them has around a 5 times the performance improvement. So the CPU is slightly lower, but the overall co-design has made the throughput through this 10 times.
Excellent, thank you. Okay, and then, the other point that we want to make here is that, and you made it, it's not just the chip, it's the entire system. So the unit of measurement, if you bring up the next slide, Alex, is actually the racks. Actually, Alex, I think I messed up. Go to the next one. I asked my friend Gemini for a little help in these slides, and this looks prettier. But so the best unit of measure is not the chips, it's the token output and the economics of the racks. And this is where we see the 5x performance, the 10x throughput, and that creates 15x increase in demand. And that's really where the annual value is, the change in annual value. It's like it's Moore's law on double steroids. But David, explain two things. One is how these 6 chips turn into essentially systems and that scale up, they scale out, they scale across, and the economics and how they've changed, this performance and throughput, and why Jevons paradox kicks in, how it compares to previous eras, and where that value lies. Please take it from there.
Yeah, that's a lot. It's just amazing. So the chips themselves are obviously on boards, and there are 72 GPUs in one rack, and the CPUs, and then in the same rack there are the communications between all of the GPUs. And what you want to achieve within the rack and across the rack is the lowest amount of jitter, the greatest amount of information being able to be available across the whole of this. So, for example, the amount of memory that's in the processors has been enormously increased and into the terabytes. So that allows no jitter, the GPUs to work in union across not only the rack, but across all the frames. And you're talking about, in terms of GPUs, hundreds of thousands, 200, 300, 400, up to 1 million of these GPUs together. And the more of them that there are together, then the faster the throughput through it, and then the faster the value of the tokens created.
And networking becomes such a key component here. Jensen referenced in this keynote the Mellanox acquisition that they made many, many years ago. So many people said, "Oh, InfiniBand's dead." That's clearly not the case. It's growing. It's growing very rapidly. Ethernet is growing. Demand is growing. It's quite remarkable. Now, Jensen shared, he put 3 graphics up on a single slide: the training throughput, the factory token throughput, and of course the all-important token cost. Like I said, he showed them on all on one slide. We're going to break it into 2 slides. So Alex, if you bring up the first of the next 2, this shows. It's interesting, David. He referenced DeepSeek a number of times. I think they hacked up. They did a college hack. It's more than a college hack. It was really a advanced engineering hack on DeepSeek because it's an open model. They took that and they juiced it, from what I understand from his comments. But the first chart on the left shows the training throughput. I think it's in months, and the time to train. You can do it. You can train faster. You can do it one quarter the number of GPUs, which we're showing here. Of course, you got the Rubin and the Blackwell. I think we're comparing it to GB200s. And on the right-hand side, you got factory throughput. We're talking about 10x more tokens per month. Again, Rubin, way ahead of Blackwell. And David, as we talked about on our last breaking analysis, people are really underestimating the degree, the pace at which NVIDIA is moving, the degree to which they have an advantage. We've seen, people claim that Google with TPUs, which are amazing, are going to, really pressure of NVIDIA, Trainium, other competitors. This just sets a new standard. Take it from here, Alex. Maybe bring up the next slide, and David, you could, or the same slide.
The same slide. That would be useful. Yes. Let's take the left-hand one there. The chart shows the training throughput in 1 month, and this is for a 100 trillion model. I mean, this is where the world is going. 100 trillion model that's being created.
100 trillion parameter model.
Parameter, yes, yeah. So the Rubin curve reaches the same level of throughput as Blackwell does, using roughly 1/4 of the GPU. So at the bottom there's the GPUs. So it only takes 1/4 of the GPUs to do that. And so that's the line there which says 1/4. And the Rubin is not just faster than the GPU, it's dramatically more efficient at scale. So it's synchronization issues, memory stalls, fabric overhead. This shortens the training cycles. This lowers the capital required per model run. This allows more experiments per year, faster iteration. This for Nvidia's customer is just so important. So on the second slide, that is the total factory throughput. As on the bottom one is the user interactivity increases. There's the number of tokens per question. So as the workloads move from batch inference to interactive agent-driven use, then Blackwell throughput collapses quickly, as you can see. Rubin sustains it much more and delivers about 10 times more tokens, value of tokens. So absolutely impressive requirement. Again, this is for the inference side of things. The training side was on the left, and this is the inference side. Okay, so this is amazing throughput through the AI factories, real workloads, which are interactive, not batched. That's where the world is going.
Well, and the funny thing to me is, so often you hear people talk about whether they're competitors or maybe they're shorts in the stock market. Talk about how Nvidia is not going to be able to effectively compete in inference. Of course, a lot of its inference today is ChatGPT inference running on Azure. But this again resets the equation because the cost per token implications of this, which we're going to show in a moment, come down. One of the things that Jensen said in his keynote is it's like double the energy, double the power to run these things, but you're doing so much more work. So Alex, if you bring up the next slide, it just brings the cost per token down. It's 1/10. So you're talking 10x the throughput and then 1/10 the cost per token. These are it's just remarkable. This is in 12 months, not the 18 to 24 months in Moore's Law, which drove the computing industry, Moore's Law, for decades. And it was just an amazing, innovation that everybody took advantage of across the stack. Obviously, silicon, but the software players, the hardware players, the Seagates of the world, the disk drive makers, the flash makers. I mean, everybody took advantage of it, all for the benefit of our productivity. Now we're talking about orders of magnitude of improvement within a 12-month cycle, David. It's just remarkable. Take us through your thoughts on the cost.
Yes, I mean, it's absolutely remarkable. And obviously what it's done is put a huge demand on the chips and memory and everything to make these, which has obviously pushed up some costs. And Nvidia has premium access to all of these capabilities. And from the inference deliverer's point of view, in that factory, if you can bring down the cost and the throughput, increase that by 10x, you have increased for that power of that factory. You have increased the amount of money that you can make for that investment, for that huge investment in the factory itself. So the economics of this are just overwhelming from one year to the next. It's just, nothing like it has ever happened before in any technology.
Well, and if you're power constrained, which everybody is, all these big hyperscalers and the neo clouds are power constrained, then then Jensen's law kicks in, which is, it's tongue in cheek, but it's true. It's buy more, make more, or buy more, save more, because you can do so much more work with, the same infrastructure, or you can do the same with a lot less. And so that's why they say, the networking is economically free. As an example, if you can take your utilization, he used the example in his keynote of a $50 billion, gigawatt data center. If you can improve your utilization by 10%, that's just, it's huge benefit that drops right to the income statement.
Bottom line.
So that is why we think that that Nvidia is in such a strong position. It does come down to the economics. They're on that curve and they've got the volume. So David, we want to wrap with what it means for competitors. We could talk about Intel, Broadcom. Alex, you bring up the next slide, AAMD and other silicon specialists. The hyperscalers are obviously a combination. They're a customer and they're quote unquote a competitor. You got leading AI research labs. In our previous breaking analysis, we talked about why we thought that the negativity around OpenAI, which persists, may be misplaced. We're going to talk about OEMs a little bit and of course customers. But let's start with the competitors. Let's start actually with Intel. I mean, it's kind of game over with regard to their monopoly and their leadership. The interesting thing when Nvidia did the deal with Intel and the sort of x86 to CUDA play, that caught our attention, David. Why don't you pick it up there? And give
yes, this is going to allow. There was always a competition, if you remember, way back in 1999, especially with the graphics, and Nvidia wanted to get access to the x86, but they couldn't. They weren't allowed to do that. So what they did was to Nvidia worked with Intel to allow the CPUs to be in the same frame. They're not 100% connected, but they will do most of the work. And that will allow Intel to be a major provider and also allow Intel to run on the CUDA systems themselves. It's not full access to CUDA, but it's a very high level of access to CUDA. So this should be a major improvement in Intel's connectivity and allow Intel to actually be a provider of CPUs in this area and increase the volume of chips that Nvidia has to give to the market.
One of the biggest risks, I think, to our Nvidia, our sanguine Nvidia scenario is, if Xi takes over Taiwan, which he said he's going to do, there's several outcomes there, right? One is that we continue kind of on as is, and China has that another lever like it does with rare earths. Another possibility is they pull that lever, and that would definitely create problems. I mean, if and when, I believe it's inevitable, China takes over Taiwan, that's going to have ripple effects, presumably in NVIDIA's, the sentiment around NVIDIA. And then that is going to, burnish Intel's value, but it's still, Intel's got to figure out how to get to where TSM is. And as we've pointed out in many, and this is probably a topic for a different breaking analysis, you can't just do that overnight. It's very hard to leapfrog, where you are. So that whole geopolitical dynamic, we'll set aside for now, but I did want to mention that as a possible risk to our scenario.
Yeah, it is. Yeah.
Bring that slide back up, Alex. Let's actually skip over Broadcom. We'll come back to Broadcom. Let's talk about AMD. They were, they've been very successful, doing a better job than Intel at x86. Now they're sort of aiming at the new leader, which is Nvidia. The problem is x86 is mature. Curve was flattening out. You've made the point to me that was the perfect time for guys like AWS to do Graviton, because x86 was had a target because it was slowing down. Moore's law was slowing down, was becoming mature, so it made sense. AMD is now got a different tiger by the tail, doesn't it, David?
It does, yes. And it's doing very, very well against Intel. But yes, it's taking on something which, in my view, they just won't be able to work fast enough at. And again, for AMD, I believe that they should be going after getting the same sort of deal that Intel has, and that will give them volume on one side. And the second thing that they should focus on, and Intel should focus on, is the edge. The edge is wide open. The data centers, which is roughly about a third of the revenue from Intel and AMD, the data centers is going to be very, very difficult for them to increase volume or not see a great decline. But the edge is open, and that's where they should focus, in my opinion.
Yeah, and meanwhile, you got NVIDIA doing autonomous vehicle. They've got libraries around autonomous vehicles. Jensen's got robots on stage doing jumping. That was kind of cute. I mean, there's a long way to go with, humanoid robots for sure. But, NVIDIA is going to go after the edge as well. So, but you're right. That is wide open. Let's bring that back up, Alex. Let's. I want to jump over Broadcom again. We'll come back. I should have put Broadcom with the hyperscalers because they're such a critical supplier to the likes of Meta and Google with TPUs, of course. But let's talk about the silicon specialists. You had Grok, which now NVIDIA is going to buy. We'll see if that deal goes through. But Grok was an interesting company, David. It still is.
Yeah.
It had some, kind of an advantage. I guess Cerebras is the other one. And there are a number of others, D-Matrix, and some of the ones that are focusing on the robotics, space. And there are definitely niches. There's plenty of opportunity in the semiconductor world to when you're not taking NVIDIA head on. But what are your thoughts on the specialists?
There's huge, such a huge, look at the rate of growth that, remember, we forecast for the growth of these AI factories. They're going to be 10 times the size of the AMD, of the x86 market. There's so much value out there to be added around the factories, in the edge. And those are where people, in my view, should be really focusing. So AMD has an opportunity to look after a huge business around these data centers. In terms of Cerebras, it's lovely technology. The important thing there is the technology at TSMC, which they are making normalized. So that is increasing the size of the chips that can go after it. And NVIDIA is able to go down that path as well. So I don't think that is a moat for Cerebras. Grok is another matter. Grok with a Q is another matter altogether. They had very, very good latency, and latency is very, very important in inference. So if you could reduce the latency, you improve demand and throughput enormously. So Grok, working together with NVIDIA, are going to work on the latency aspects of that, putting that into the racks that NVIDIA have, and that will be a very powerful combination.
Well, it's going to be interesting to see if that Grok deal goes through. ARM NVIDIA didn't go through. I guess it was the UK who kind of killed that, right? We'll see if the Grok deal goes through. I feel like Lina Khan never would have, let that go through. But Trump's got his hand in NVIDIA's pocket with the U.S. taxpayer. So we're getting a little lick off the cone with Nvidia selling chips to China. So maybe they will allow that. Bring that back.
Yeah,
thoughts on
the other thing is that from a national point of view, going against Nvidia is going to make it easier for China. So I don't see the same sort of benefit of second. There's going to be plenty of competition from China to keeping Nvidia honest.
100%. That's a really key point. I'm glad you brought that up. All right, bring that slide back up, Alex, because I don't want to look at myself. So Broadcom, we can put Broadcom and the hyperscalers together. Broadcom is a critical ASIC supplier. They kind of handle all the back end, and they deal with the factory TSM and the foundries, and whereas Google with TPUs,
designs them, yeah.
Meta, they just do their own design. Amazon is not a customer. Well, I'm sure they're a customer of Broadcom for some stuff, but they're not, as large a player or a customer as is Google with TPUs. So let's break that up. So Broadcom, to me, David, has a diverse enough business, and is a critical supplier to OEMs and a number of other folks. I don't see their business going away. I do think I do think they have some unique advantages relative to, say, an AMD. Having said that, you have put forth that you've questioned why AWS, Microsoft, and even Google with the TPUs, you've questioned the economic viability of them continuing to try to provide alternatives to NVIDIA GPUs. Explain that.
Well, it's a question of whether this is useful to their main survival, which is going to be for every company over the next 10 years. So for Google, they have such a great history in this area. They were the people who made the TPUs, introduced it in scale to begin with just incredible capabilities. But this is a different business now. They have to look after their searches. They have to look after the quality of it. And if they make their developers not able to use CUDA, all of the improvements there, not to be able to use the best technology there is there, they are going to put the dampers on the quality of Gemini. So it's absolutely vital to me is that they say, okay, this is not our core business. We are going to buy these like everybody else, and we're going to focus on our core business and focus on creating the best model in there, and not worry about the equipment to do it, because they cannot compete with Nvidia, but they can compete with OpenAI. But if they do compete by keeping their own, they're going to put a large weight on each foot.
Well, they can afford to keep their own. The question that you're asking is, does it make sense for them to keep their own? Gavin Baker, in our last breaking analysis, we did a little clip from him. In a conversation he had, I forget with whom, he was basically positing that Google has, let's call it a $30 billion TPU business, at a steady state, and that, half of that gross margin is going to go to Broadcom, called 55%, but let's call it half for easy math. So 15 billion going to Broadcom. He made the point that that Broadcom's COGS for the semiconductor division is 5 billion. So they could literally hire everybody out of Broadcom, put them in Google, and save 10 billion. Of course, that's not that simple. It's an oversimplification. But the point being, they're paying a lot, and so his premise was, as a result, Google's going to bring all that in-house. You would say, no, they're not.
I would say no, not sensible. I mean,
They might because they got more money than they know what to do with, but it's not. You're saying it would not be an efficient use of capital, in your opinion.
And even worse than that, Gemini is so important to them. All right, Gemini is a piece of gold for them, and if they hold Gemini back, remember those charts that we were looking at. If it takes them 4 times longer to develop the next model, that is going to be suicide for them. So that they have to just recognize they have to have the best and drive Gemini as fast as possible. And the best, unfortunately, is not a TPU, and it's reached the end. It cannot compete in the volume.
Explain that. Explain that it's reached the end. Why aren't TPUs and ASICs, Trainium, why are they not on the same curve as Nvidia?
Well, there's several reasons. The first is volume. They are 1/10 or less the volume of Nvidia, and the volume drives the learning curve and Wright's law. The second is that in terms of the TPUs, the bottleneck for them growing is the network, and as they're growing to hundreds of thousands and millions of GPUs, that is where their bottleneck is, and they won't be able to grow past that. And the same is true of the ASICs. The ASICs can grow, yes, they'll get to better, but it's not the ASICs that matter. It is the whole frame that matters. So Nvidia, they would have to, Google, for example, would have to go into that whole business of providing all of that capability and doing it for a marketplace of 1/10 of that of Nvidia. And that just, to me, does not make any sense whatsoever. If they do that, they will cripple their own development of AI and Gemini, and that would be a bad outcome. A bad outcome for them and a bad outcome for the business, for us as well.
And I guess you would say the same thing about Trainium. I mean, if I asked you, well, why can't, you kind of just answered it. Why can't the Graviton playbook, I think we've already answered it, apply here? And the answer is Graviton was aiming at x86, a mature, petering out, if you will, a flattening curve, I should say. Shouldn't petering out, but remarkable what x86 delivered for 20, 30 years. But the flattening of that curve, it was much more sensible for an Amazon to develop something like a Graviton. That's not the case here. The pace is so fast. And at the same time, by the way, Intel sort of lost its way. And so, we have to consider that. Let's bring that back up, Alex, and let's go on to the AI research labs. There's really 4 frontier labs that are vying for, dominance now. It's OpenAI, Anthropic, Google, and Grok. We're putting Meta in a second tier. So let's put Llama and Meta in the second tier for now. We're not as optimistic about Meta, but who knows? You never count Zuckerberg out. But so the interesting narrative is that OpenAI, we all know they're out over their skis in terms of their commitments on debt and the circular investments and vendor financing and all that stuff. However, Nvidia is very close to OpenAI. They've got this interesting investment in OpenAI, and OpenAI is not competing with Nvidia in the same way that Anthropic is kind of in bed with AWS and Google itself with TPUs. So who's going to get the allocation? It's for the latest and greatest. It's going to be more likely OpenAI and Grok. Not that the others aren't going to get allocation. They will. Sundar Pichai said, no, we're still going to rely on NVIDIA. Certainly AWS makes that point that, no, we got a great relationship with NVIDIA. And of course, Microsoft as well. But your take on the foundation model vendors, why you're optimistic about OpenAI's prospect, and what the announcements that Jensen made particularly the Vera Rubin, mean to the foundation model vendors and generally in OpenAI specifically?
So OpenAI has the leadership in terms of users. People is screen time, usage by far. Other people saying that Gemini have trying to catch up on showing that on some metrics they've brought up. It's a big difference between them. The second player is Anthropic with Claude, but OpenAI is way ahead. So assuming that they can keep that that difference, they will come out as winners in the long run.
Way ahead in terms of adoption.
Of adoption. And the things that are going to help them is that they have focused on getting as much CPU, as much processing as possible. So they're getting it from anywhere they can. I mean, whatever is out there is goodness. And they have got more of that. Grok and OpenAI have, to me, won that battle in terms of pure volume. OpenAI in combination with Microsoft, of course. So that's going to make life very difficult, in my view, for Gemini long term. They've done very well at the moment, and it's going to make it very difficult for Anthropic. So those are for me the two winners. I would say the most likely winner in the center is going to be OpenAI. I think Grok is going to have a very high probability of doing very well at the edge, and be very much in competition with Nvidia there.
With Nvidia?
Yes, at the edge.
Oh, you're talking about Elon designing his own chips.
Oh, for the edge, yes.
Yeah, okay.
Yes, right. He's given up all his stuff for this data center.
Right. He had an initiative to build their own data center chips and said, this is a waste of time. He figured that out early on.
He was smarter than much. Yeah.
Alex, bring up that slide again. So let's go quickly. The OEMs and the edge, really the edge opportunity is what you talked about. We're talking about Dell, HPE, Lenovo, Supermicro. I mean, basically, it's the guys who can get the latest and greatest, package it, and get it out into the market without the stuff melting. They're going to win, right? And that's where Dell has done really well there. They're a big supplier to XAI and others. I mean, there's such demand here. I mean, it's really important to point out this is not a zero-sum game. There's plenty of room for the LLM players. There's plenty of room for the OEMs, and there's big enough market for the market is such huge demand, and it's so constrained right now. Until that changes, any negative sentiment that we have around NVIDIA's competitors, if they can produce a GPU, it's going to get consumed, and so that is maybe the case for continuing with these initiatives.
Well, they shouldn't throw away what they have. They've invested in. They should sell as much of that as they can. But it's the investment of after 2 years down the line that's where things become. That's not worth it.
I want to focus our attention on the bottom left here, which is customers, AI strategies, and spending implications. And I want to just share some of the research that David has done and David and I have been working on. There's a narrative out there. There's a conventional wisdom says, get your data house in order before you waste a bunch of money on AI. And the reality is if you can pick a data set that's relatively clean and then use AI to improve it, or even if it's not relatively clean, but get on the AI curve. The modeling that we've done shows that you're over time, let's say a 5-year period, the value that you're going to get is going to be much greater than if you don't get on that curve. That's sort of number one. The second is our models are indicating that the percentage of revenue that is going to go toward tech spend, which today is, let's call it, IT spending is probably about 4% IT budget's about 4% of revenue. We think that's going to increase dramatically to as much as 10% or even more as we shift to AI because of the benefits and the productivity benefits that you're going to get. And we expect that people are going to shift quite dramatically in the next, 3, 4, 5 years from legacy sort of infrastructure and approaches to application development, et cetera, dramatically shift to AI technology, specifically in the form of accessing tokens through APIs and other mechanisms. So David, I wonder if you could pick it up there and talk about customer strategies, getting to AI as fast as possible, not taking incremental short steps, but going to as fast as you can to getting your AI infrastructure in order, your data, your database in order, not necessarily cleansing your data, but get your data infrastructure in order, and then go hard after AI, put in a single project, learn from that, get the next one, the next one, the next one, and create that flywheel effect. Please pick it up from there.
Yeah, so from the budget point of view, as you said, IT is going to spend a lot more on tokens than they are on MIPS. So that the ratio is going to be 10 to 1 over the next decade, at least. And so those tokens are the value, and that's the value that you need to apply to the problems of your IT problems of your organization. So how do you get those tokens? Working on that? Well, first of all, you need good latency. So putting the tokens adjacent in the same latency area as your database, that's very, very important indeed. And then you can use the tokens as the intelligence to improve the access to the data, the quality of the data, and work out how to improve the processes, the business processes. That is going to be far more valuable. And the amount of that value coming with improvements there is going to make that a much better way of doing it, of starting with the value and improving what you've got there, rather than trying to spend a lot of time improving your data. That is, you're putting all of that work into something which you should leave to much more powerful forces to deal with. I'm not sure if I explained that very well, but it's an incredibly, to me, an incredibly important change in the whole of the way that companies should look at creating value to their organization, to their IT systems through the tokens rather than the other way around.
Well, we're going to be doing some more research on this and sharing that with you. These are somewhat these are kind of counterintuitive to a lot of the narratives that are out there, but we got to wrap there. David, thank you so much. And thank you, everybody, for watching Breaking Analysis. We'll see you next time.